Every electronic device around you like smartphone, smartwatch, laptop, and even your TV relies on tiny chips working together in perfect harmony. But how do these chips communicate? For millions of devices, the answer is a simple, elegant protocol called I2C. Today, we're diving deep into the history of I2C communication, how it started, why it was invented, and how it became one of the most important protocols in modern electronics. Chapter 1. Birth of I2C 1982. The story begins in 1982 at Philips Semiconductors, today known as NXP Semiconductors. Electronics were growing increasingly complex. TVs, audio equipment, VCRs all required multiple ICs. But connecting these ICs took many wires, making circuits bulky, expensive, and difficult to design. Philips engineers created a solution, a way for multiple chips to communicate using just two wires. They called it I2C, Inter-Integrated Circuit. Chapter 2. Why I2C was needed. In the early 1980s, protocols like UART existed, but they were only point-to-point, one device talking to one other device. Philips needed a bus where multiple chips could communicate over the same lines. So I2C was built with multi-master capability, multi-slave support, address-based communication, and just two lines, data and clock. Chapter 3. Early I2C 1980s. In the early years, I2C was used almost exclusively inside Philips devices. Remote control decoders, TV tuners, audio processors all relied on I2C. The first version supported a speed of 100 kHz, now known as standard mode. Chapter 4. I2C grows 1992s. By the 1990s, electronics manufacturers around the world recognized the value of I2C. In 1992, the protocol received its first major upgrade, fast mode, boosting speed to 400 kHz. This made I2C ideal for sensors and memory chips in more capable devices. Chapter 5. Expanding address space, late 1990s. As the number of devices on a single bus grew, the old 7-bit addressing system wasn't always enough. So, in the late 1990s, I2C added 10-bit addressing, allowing for far more devices on the same two wires. Chapter 6. The 2000. Speed revolution. Entering the 2000s, modern electronics demanded much higher speeds. NXP responded by introducing Fast Mode Plus, 1 MHz, High Speed Mode, 3.4 MHz. These improvements made I2C ready for mobile phones, laptops, and advanced embedded systems. Chapter 7. I2C in modern electronics, 2010 to present. By the 2010, I2C became a universal standard. Almost every microcontroller, Arduino, PIC, STM32, ESP32, Raspberry Pi comes with built-in I2C hardware. Today, I2C powers temperature and pressure sensors, accelerometers and gyroscopes, real-time clocks, touch controllers, EEPROMs, displays, and countless industrial and consumer applications. Chapter 8. Related technologies, SM-Bus, PM-Bus. I2C also inspired several variations. SM-Bus, developed for computer motherboards, borrowed heavily from I2C but added stricter timing rules. PM-Bus followed, designed for power management systems. Chapter 9. Why I2C still matters. Even after more than 4 decades, I2C remains incredibly popular. Why? Because its core idea still works. Simple, reliable, two-wire communication for a world full of sensors. No matter how advanced electronics become, they still need simple ways for chips to talk, and I2C delivers exactly that. From old CRT televisions to modern smartphones and IoT devices, I2C has quietly powered generations of technology. A brilliant idea from 1982 continues to shape the future of electronics. If you enjoyed this deep dive into the history of I2C, don't forget to like, share, and subscribe for more engineering stories. Thanks for watching.